All right, grade 11s, we are still on our analytical geometry, and this is your second lesson. And it is my wish that you will enjoy this one so much. Well, here we have something new in this lesson, and it is the lesson we are going to learn about the angle of inclination. Well, the angle of inclination of a straight line, please remember in the previous video, we learned how to calculate the gradient of a straight line, even how to determine the equation of that straight line. So in this video here, we're going to talk about the angle of inclination. And please listen closely. It is the angle that a straight line makes with the positive side of the x-axis. So that will be the angle of inclination right there. So if you have a straight line, just make it a point that you measure from the positive side of the x-axis. Even if you look at this diagram here, this side is the positive side of the x-axis. So the angle of inclination, you measure it from here all the way to the straight line. So you measure it from here to the line. So you come from the x-axis to the straight line that you've got. So you're seeing that if a line is slant to the right, such as the first one here, you can see that the angle of inclination will be smaller than 90 degrees. It will be an acute angle. However, if the line has got negative gradient, such as this one over here, you will see that we will have an obtuse angle, an angle that is greater than 90 degrees. So as you can see, this is actually what we have, and we are going to be able to calculate the gradient of that. So to really understand what the angle of inclination is and how to calculate it, I am going to enlarge one of these. In fact, let me start with the first one. Let's try to enlarge it a bit, and then we see what to do here. So look at this one like this. If you look at it, I want us to remember what gradient is. If you remember what gradient is, let's say we have these 2 points, that point and that point. If I wanted to calculate gradient there, I was going to say change in y, which will be this side, change in y, over change in x, which in this situation will just be this one over here. So if you have a change in x over here, that's how you can calculate gradient. Please notice your gradient will be equal to change in y over your change in x. All right, so as you can see, that also reminds us of something, doesn't it? Because back then when we did trigonometry, if I have a triangle such as this one that you're seeing here, this side, which is change in y, was called our opposite. The opposite with respect to angle theta here, and this side was the adjacent. So if you remember, we said for our trig ratios, this is what we use, okay? So if we use this, we know that the tangent of a function, say this one here, is equal to its opposite over the adjacent. So in this situation, notice how tan of this angle theta we've got over here is actually going to be equal to the opposite, which is also equal to change in y. That is tan theta, excuse me. So it will be equal to change in y over change in x. And we know that one to be equal to m, don't we? That is the gradient. It's exactly the same thing. So that is why in this notes of yours, all I did was to give you this formula, which says gradient is equal to m, which is equal to tan theta. And of course, we already know how to calculate gradient in this manner. So what am I saying? At this point, if we know the gradient of a straight line, we can easily calculate the angle of inclination of that line. That's what I'm saying. So let's quickly try that one in real questions. Let's figure out what we can do. Don't forget the new thing that we learned is that m itself is equal to tan theta, where theta is the angle of inclination. All right, here let's go and let's get started. So to begin with, I am going to make sure that we create a bit of space here. In fact, let me just get a lot of it. I'm going to just have a new page here. Let's enlarge this a bit so you can see it clearly when we're talking about it on a new page. All right, look at this. Well, I want us to forget the question for now. I want us to just plot these points that are here. Look at this point, and that point. So I want us to try to sketch them on the Cartesian plane. So let's go ahead and do that. Let's put our y-axis and x-axis somewhere. So we can do it slowly but surely. Here. So I am answering question A in case you're wondering. I just thought, let's first of all put those two coordinates in place. So I would like to put coordinate 1 and -4. It should be, let me put it somewhat here and say that's 1 and -4. Okay, and then we also have -2 and -7. I'm just going to put it somewhere here and say that's -2 and -7. I want you to be able to see this straight line. So since this is a straight line, you see I'm just going to project, or rather to draw this straight line, join those 2 points, and I want to just carry on with it. Carry on until it cuts the x-axis, because that's when it becomes interesting. Remember, if we want to find the angle of inclination, we'll be talking about this angle over there. That will be the angle of inclination theta that we're talking about. So in this situation, although the question is really just asking you to calculate the gradients, I would like to go ahead and also calculate the angle of inclination of these straight lines. So let's go ahead and calculate gradient. It shouldn't take us a long time. So I'm going to say -4 minus -7. You do remember that gradient is y2 minus y1 over x2 minus x1, right? It's there on your notes. So you can calculate gradient using this way or using angles of inclination. So either ways, you get there anyway. So we have already said our y2 minus y1 divided by x2, which is 1 minus -2. So here, your gradient on top, it should be 3. And at the bottom, you're noticing how it is going to just be positive 3 as well. So you have 3 over 3. Your gradient will be equal to 1 for that. So now we are saying the gradient of this line is equal to 1. If ever I want to calculate theta, the angle of inclination, the relationship is m is equal to tan theta. So in this situation, you can say now 1 is equal to tan theta, which leaves you with theta being equal to the second function, in fact, the arctan of 1. And that is, of course, well known to be 45 degrees. So that is all that we do. So I want us to do that with all these 4 problems that we have over here. So just do the same. Calculate gradient as well as the angle of inclination on that. Okay, so you can go ahead of me. You can pause the video, try it yourself. And then if you're already on B, so I'm not going to keep sketching it, but let me sketch this particular one so we can just have an understanding of what's going on. I like it when you see it. Okay, so let us plot -6 and 3. This coordinate over here. It should be somewhere, let's put it up there. I'm going to say that's -6. It doesn't make much sense if it is all the way up. Let me put it -6 and maybe 3 is over there. I'm just going to say this is -6 and 3. Should be able to sketch or to plot these points. And then let's go to 3 and 0. 3 and 0 should be a point somewhere. Okay, let's put it somewhere there. 3 and 0. So I am going to draw a straight line like this that passes through both points. And there we go. So that is a straight line that we've got. So this straight line, if I want to find the angle of inclination, I measure from the positive side of the x-axis, so right there, all the way to the line. So this is the angle theta that I'm talking about. So as you can see, this one will have negative gradient, so the angle that we get should be an obtuse angle. So let's go ahead and calculate the gradient first and then figure out what happens after that. So I'm not going to write the formula anymore. So it's 3 minus 0 divided by minus 6 minus 3. So you can see in this second situation of ours, the gradient will simply be negative 1 over 3. You can see it is 3 over minus 9. Of course, you can simplify it to this. Well, using the relationship that we talked about, hope you're still here, the gradient we use is the gradient of that straight line. So it means you put negative 1/3 here is equal to tan theta. And like I said before, remember, this is when you press the second function on your calculators that you use to calculate the angle itself, isn't it? But if you have negative gradient, you realize that your calculator will only give you a negative angle actually. And if you do it with this one, you will definitely get negative 18.43. So what you do, remember I said this should be this part here should actually be an obtuse angle. So to get to your obtuse angle, you just add 180. And some of you do remember that tangent has a period of 180. So to get your actual angle, you just really do that. So in this situation, I'm going to do that. And after I add 180 to that, I'll get 161.55 degrees. So that is what you have in this one. Okay, good. I hope you're actually seeing what we are doing here, calculating gradient and how gradient affects the angle of inclination. Perfect. It's important that we just finish C and D, although there is something else that I want you to see on C here. So we are doing this question over here. Okay, we are doing this one. So the first thing we do, maybe we should just again try to sketch it. Wow, what would be the harm in doing that? Let's do it. So I'm going to put my y-axis and x-axis. Okay, something of that sort. Could be better. So let's sketch negative 5 and 1. Do you see that I needed space to the left more than I needed space to the right? So I'm actually going to just say negative 5 and 1 is this. Let's put it here and say that's negative 5 and 1 right there. And this line also has to pass through negative 5 and 6. Well, I'm going to have to put it over there again. Its x is still negative 5 and y has increased to 6. The beauty of this is that you are seeing that the x values are not changing. And that should remind you of what I told you in your first lesson. If your x values are not changing, it means you have a perfectly vertical line. It's a vertical line. And if you have a vertical line, it is actually parallel to the y-axis and perpendicular to the x-axis. So remember the angle of inclination, The angle of inclination, we measure it from the x-axis, the positive side of the x-axis, to the line. So this one will simply be 90 degrees. We can easily calculate it. The reason we are not going to bother ourselves calculating gradient is because we know that here we mentioned how gradient at this point will be undefined. So the angle of inclination at that point is 90 degrees. So that is actually something different about C that I thought I should point out before we make too many assumptions. Well, let's also talk about the horizontal lines. We don't want to leave them out. So again, this is a horizontal. I actually told you already, so you should be expecting it to be horizontal. So here is the y-axis, here is the x-axis. Plot the points that you have. You have negative 2 and 1. I'm going to put it here as negative 2 and 1, that coordinate. Okay, and you also have 3 and 1, so that is over there. 3, and 1. So you see what changed is the width. How high it is did not change. So the y value is still the same. So this line right here, no matter how hard you look at it, it will stay horizontal for you like this. And it is exactly parallel to the y-axis, rather to the x-axis. So if it is parallel to the x-axis, the angle of inclination over there is really going to just be 0 degrees. It really coincides with the x-axis. So there is no angle between this line that we've got and the positive side of the x-axis. And one thing to remember is that I said the gradient of this is always 0. If you have forgotten the angle of inclination, just go ahead and say theta is going to be equal to the arctan of 0, because the gradient is 0. You will also get 0 degrees. Okay? Well, if you want, maybe you forgot that the gradient of a horizontal line is equal to 0, you can use these two coordinates and make sure you convince yourself that this is actually 0. Is that fine? Okay, well, another thing I want us to do is this question over here. We just want to make sure that we understand everything. So come back to this page over here and let's look at this question here. So look at it closely. It's still the same type of question, okay? I want you to do that one first before I before I give you the solutions. So just make it a point. Is this one that I want? So let me make sure that you can see it so well. Let's see. I hope you can see it. So it says calculate, rounded off to 2 decimal places, the inclination of the line joining the points, those points that are given. So do it quickly and then look at the solutions that I am putting up now. Right? I gave you this one to do, this one that is still highlighted. So let's do it quickly. We are now answering these two questions, A and B. So to do that, if we want to draw those lines, you're welcome to do it, but I think at this point we get the idea. What we need is the gradient between A and B. So if we can get the gradient between A and B, we can easily calculate the angle of inclination. We know that if the gradient is negative, we will eventually add 180 to the angle of inclination. If the gradient is positive, we keep things the way they are. So let's go for it. I think calculating gradient is simple. So here I'm already substituting -3 plus 1. I think you're seeing why I'm saying plus 1. That's a 3. Okay. And then you have -2 minus 3. So you're seeing that the gradient of AB, between those 2 points that we were given, we are seeing that that gradient is equal to 2 over 5. So since the gradient is 2 over 5, we can easily get the angle by saying this formula. This is the formula. So we want to get the angle of inclination. So you just put your theta, according to what we know, is arctan of the gradient. And the gradient is 2 over 5. You don't really have to put this step, but do get the solution for that, please. Well, if you're right about everything, you should get 21.8 degrees for this question right here. Okay? I think you're getting it. Let's do these ones, C and E. Let's calculate the gradient between those two, and let's see how fast we can go about it. So that's B. Let's mark it. We want the gradient between C and E. So as you can see, I'm going to just say -4 minus 5, and I'm going to say divided by 2, 2 minus 5. In case you forgot, you put these ones as your ones in this situation, x1, y1, and this is x2, y2. And then you substitute it into the gradient formula that I gave you. So the gradient of CE will end up being Let's simplify it together. So it does look like it's -9 on the numerator, and it should be 7 on the denominator. So that is what we've got, -9/7. We have gradient that is negative. So when we go and we substitute to get the angle of inclination, we are expecting an obtuse angle, but firstly we will get negative angles, then we add 180. So what I said to you, oh, don't forget this is -9/7, excuse me. So your theta is going to be this, okay, of -9/7. So if you're following, you will find your theta, use your calculator, you get -52.13. Now, because this is negative, please, all you need to do is to add 180 degrees. And when you add 180 degrees, you should get your theta of 127.87. All right? This is very simple, I should think. So since everything is sorted, so let's figure out this last easy question. Okay, I think you're beginning to understand what this angle of inclination is. Remember, it's relatively new to you. So let's go to this one, this question over there. And let's make sure that we do a bit of justice to it as well. So here it is. I think now you can see it a bit better. So you are to calculate the gradient, if possible, of a line with the inclination that is given. So now you are given the angle of inclination. Like seriously, you are now expected to calculate the gradient. I think you know what to do. We know that m is equal to tan theta, and I'm not going to waste anyone's time here. So since you want to calculate gradient and you have the angle of inclination, we should be able to calculate it very fast. So it's a matter of you saying tan 135 really, so you can get gradient. I'm not going to put all those steps as we're going. So your first gradient should be -1 if you do it right. The same applies to B. When you say m is equal to tan 45, for B, you can see that your m is +1. Let's do C. C, we have 60 degrees, so m is equal to tan 60 degrees. That's the angle of inclination given, so there's no need to waste time. So the gradient for C, tan 60 is actually a special angle, right? So we should find it very simple to find. So in this situation, it would be √3. Let's go for D. You're seeing that the angle of inclination given at D is 150. Again, you can see how that is an obtuse angle, right? So we are expecting gradient to be negative. So in this situation, when you put tan of 150, you're definitely getting -√3/3 as your gradient. And as we were expecting, we will always get to that value, which is 90 degrees. So when you go and say m is equal to tan 90, we're talking about a vertical line now. This will be a vertical line. And when you try to get this, it will just be an undefined value. So this will be undefined. So I believe you are getting the concept, the whole concept here. You are actually grasping what is going on. So now I would like to bring it to your attention that they don't just ask you to calculate angle of inclination and just calculate gradient. They try to make it interesting in your examination. So look at how interesting they can get. There we are. So you will have a situation such as the ones we're seeing on the board. So I'm going to create space for the first one mainly. What you are now being asked for is to calculate theta, and everyone can tell that that point right there is not an angle of inclination of any line. In fact, if I may, notice if I have the gradient of AB, this is AB. If I would like to make an angle of inclination to AB, it has got to be this one. So it will be this whole thing. That will be the angle of inclination at least. We can call that an angle of inclination. So for you to see clearly, let me start that again, making it a bit bigger. I want you to see properly. Okay, let's remove what we did before. Okay, here is what I was explaining. If where theta is, as you can see, it is not an angle of inclination, but the angle of inclination will be of two lines. So if you want the angle of inclination of line AB, you have to measure from the positive side of the x-axis to where the line is. And let's just call that one alpha. And again, there is another angle of inclination since we have another line. So here is the straight line that we've got. And if we want to measure an angle, we measure from the positive side to the line. Let's call that angle beta right there. At least we know that we can easily calculate alpha and beta in that question. Let me make sure that all the other questions are not disturbing this one particular question we are talking about. Okay. We'll get to them later. Let's focus on this one for now. Okay, so what you can do to get alpha, you know that you can easily get alpha by calculating the gradient of AB. I am pretty sure you can see that. So why don't we go ahead and calculate the gradient of AB together? 6 minus 1 divided by -1 minus 5. So the gradient of AB should be very simple to see now. Use your calculator. You have your 7 and your -6 at the denominator. So as you can see, it is -7/6. So to get the angle of inclination, which we are calling alpha now, I'm going to say m is equal to tan alpha. Okay? It's alpha that we're talking about. So at this point, to get alpha, I may just have to say the tan inverse of -7/6. Well, because it's negative, we expect to actually still add 180 at one point. So let's go ahead and use our calculators to get this alpha first. You can see that if you use your calculator, you will get -49.4. I'm getting let's round it off to 40 here, degrees. And don't forget, we add 180 degrees. So our alpha will become easy to see. At this point, we can see how that is going to be 130.60. Well, we got one angle. We know that this is 130.60. It's just that it's not the angle that we were asked. We were asked for theta. We got that one. Good for us. But how do we get theta? You may wonder why I'm going on and on about calculating alpha and beta, but in no time at all, you will notice that alpha actually is the angle of is the exterior angle of this triangle over here. So if you look at this whole triangle here, this part, you can easily see that alpha happens to be an exterior angle. So it is clear to us that alpha can easily be written by saying is equal to theta plus beta. So you can really write alpha is equal to theta plus beta. And that is because it's an exterior angle of a triangle, which is equal to the sum of opposite interior angle. Okay? So, if you see and appreciate the statement here at the bottom, what will help us is that we will realize why we are calculating these other two angles. So at this point, I'm going to actually ask us to calculate the gradient of CD. So it should be easy for us again, 6 minus 0. We are now calculating the gradient of this line over here. So 6 minus 0 divided by 3 minus 2. As you can see, it's again simple to see. So looking at this, we can see how that is 6/5. So since this is 6/5, we can easily get the angle beta now by saying this is equal to tan beta. And we know how 6 over 5 is going to be equal to tan beta. Use your calculator, please, and see how beta is equal to 50.19. There. So we got our beta already as 50.19. So let's go and substitute into this formula that I finished making here. So please see how alpha is an exterior angle. Well, if you do not see that fast enough, you can as well get this angle here. By subtracting 130.60 from 180, you get this angle. When you get it, you can then use interior angles of this triangle here. So I'm hoping whichever method you use, you get to the answer anyway. So let us quickly finish this one and get the answer for this unknown angle now. Okay. Well, if you remember, let's put it into the equation. Alpha was already 130. We are working with this equation down here. So in place of alpha, I'm going to put 130.60. And then theta is what we are looking for. And beta happens to be 50.19. And therefore, we can easily see the value of theta now. So use again your calculator to get to that solution. So you can see you get your 80 point, it should be 80.41 degrees. You see, that's more of an examination type of question. You'll be calculating, you'll be using angles of inclination to get to the solution. So I think you're now grasping this concept. And because you are, I'm going to make sure that we do a quick one, a second one very fast. So I am going to pick this one. We'll do this one last. So let's pick it all the way down. It's this one that I want for now. So let's do this question here together. And for us to appreciate how it's going to go, let's make it even very big for us to see properly. Right, again, it's the same situation we find ourselves in. I think it's easy to see this time around. You can work this one out first and then check if your solutions will be the same as mine. In this situation, all we'll be required to do is to get the angle of inclination of this one, and we get the angle of inclination of this one, and then we see what to do. So again, I'm just going to call this one alpha again and call this one beta. Not that it matters which one you call what, but let's just see. I need the gradient of AB. I think it's clear that I need that. So let's go and calculate the gradient of AB so we can get beta. So in this situation, it will be 5 plus 1. 5 minus. So it will be 5 plus 1. Divided by 1 minus 2, which will be 1 plus 2. So this one was a very easy one to sort out. Okay? So your gradient is going to be equal to 2. So that is your gradient of AB. It's as good as you're just saying 6 divided by 2. So getting beta is not going to be a problem. So we're going to say this 2 is equal to tan beta using the formula that we talked about. So our beta is acute, as we can see. Our angle is simply, let's use our calculator quickly. It is going to be 63.43. There, we got our beta. Well, let's go ahead and calculate the gradient of CD. We know that if we ever want to calculate alpha, we have to calculate the gradient of that line. So gradient of CD is, let's just say 5 minus 2 over 1 minus 3. Do that. So there's a 3 and a negative 2 at the bottom. So the whole answer will just be negative 2 over 3. So you can just write your answer as negative 2 over 3. It should be fine like that. Okay, so that's negative 2 over 3 is your gradient. So from what we know, m is equal to tan, and in this situation we're talking about tan alpha, right? So we can easily get alpha if I put minus 2/3 here. I'll say is equal to tan alpha. So getting alpha is going to be easy. So if you use your calculator properly, you should get your alpha is negative 33. Should be in degrees, okay? We are working in degrees. Negative 33.69. And since it's negative, from what we said, you just add your 180. So definitely to get your alpha, you just add those two and you should have 146 at this point, and it will be 146.31 degrees. Rather, let's put the degree sign over there. Okay, perfect. So if you're still following, you remember the relationship between these angles, I hope. Look at them. Look at these angles. So from what you are seeing, and for the same reasons I did last time, look, alpha is actually going to be equal to theta plus beta. And it's that same reason. Exterior angle of a triangle happens to be equal to the sum of opposite interior angles. Okay? So that's your reason over there. So by so doing, I'm sorry, I'm going to have to erase this part. So by so doing, you can easily calculate those two angles. So in place of alpha, I'll put that 146.31. And then I'll say it is equal to the angle we want plus beta, which we know beta is 63.43. At this point, getting theta will just be a joy. It's just a matter of picking up your calculator and getting it. So as you can see, you should be able to get your 82.88. That will be your angle theta for this one. So I hope you managed to understand these two questions that are actually very similar for your own good. So I'm not, I know it's getting long, but I'm not going to leave this lesson until I do this last one that I gave you here. Let's just rush through it quickly. I will try to be a bit fast about it. I hope you're here. But there is something different about this question. It's not exactly the same as the other ones that we just did. So look at it. If you look at it really, you can see that it's a little bit different to the other ones. So look at it. If you want the angle of inclination of this line, you have to work like this. Now, notice what's happening here. This will be the angle. Let me just extend the x-axis. Okay? So this right here will be the angle of inclination of AC. Let's call that one. We cannot call it theta anymore since theta is what we want. Let's call that one alpha. Let's try to get alpha first, and I'll show you why alpha is important. So to get alpha, we need the gradient of AC. That is not a problem. Gradient of AC, okay, C is 5 and 0. So the coordinates there are 5 and 0, and this is 0 and negative 6. So make sure you substitute properly. 0 minus 6 divided by 5 minus 0. So at this point, I think you can easily notice the gradient of AC. So it is 6 over 5. So to get the angle alpha, you just have to go and use that formula for gradient, okay? M is equal to tan theta, and this time is alpha, so I just took one quick shortcut there. So alpha in this situation will be some 50.19. Okay? So here is what's important. This alpha, where it is, if you look at it, it's vertically opposite. Let me highlight it in red, this one, and then this line here. So look at where alpha is. If we say that this is 50.19, we are confident that even this part here, this part of theta should be 50.19 as well, because those are vertically opposite angles. So getting alpha helps us to get to theta. So all we need now is just this top part, because the bottom part has been taken care of. So if we can find a way of getting that part, then we are ready to tell the value of theta. And it is not going to take us too long to figure out. So for the sake of explaining, I am going to just erase this part that I put in just now. So I want you to look at the line BC now. So if I just extend it, maybe, you will see that the angle of inclination here will be this part. If I calculate the angle of inclination, I'll be calculating that part right there. That's the angle of inclination. Let's call that one beta. But you see, if I calculate beta, I can simply subtract it from 180 to get this part that we do not have. So that is why calculating beta is actually going to be important. So let's go ahead and calculate beta. So to calculate beta, I'm going to use the gradient of that one. So let's calculate the gradient of AC. So that will be, don't forget, A is -6, 0 and -6. And for C, the coordinates at C are 5 and 0. So I'm going to say -6 minus 0 divided by 0 minus 5. So the gradient of AC will be in order in no time at all. So it's 0 minus 5. So it does look like it will just be 6 over 5. Interesting. Positive gradient. Okay? So if you carry on like that, you will easily get your 50.19. Is that 50.19 again? No, we got 50.19 already. We already calculated the gradient of AC. Did you see that? So the gradient that we actually want is the gradient of BC. Please notice where we are. These lines are making us work too hard now. We already calculated this gradient right here, so we need not to calculate it again. So to calculate beta that is here, we can see it's an angle of inclination of this line, and this line happens to be BC. So it is the gradient of BC that I'm looking for here. Excuse me. So this one will be 0 and 2, and that one is 5 and 0. So again, it will be 2 minus 0 divided by 0 minus 5. So now that one is clear to you now, that the gradient of BC is equal to, that one will be -2 over 5. So let's get our beta quickly. Let's get it quickly. So go to your calculator and say beta is equal to this. All of this of -2 over 5. If you use your calculator wisely, you should be able to get the correct answer of -21.80. And because it's negative, you just add 180 to it, so you can get your obtuse angle, which in this situation will be 158.20. Okay, let's go and reason now with our diagram and our values. So we know that this is 128. We got it as 128. It's 58.20, right? 158.20. Okay, so if you subtract this whole thing from 180, you should be able to get your 21.80 here. I think it becomes clear now what we do to get theta. So you can see that to get our theta in this situation, all we have to do is to put that angle that we got initially. You remember this angle that we got initially? It was 50.19 here. And then now we also then got 29.80 over there. So to get the whole theta, we just have to add those two values. And if you add those two values, let's add quickly, you should get 71 point, if you use this exact answers, you're getting 995. So I'm just going to round it off to 72 degrees, this one. Okay, this was actually quite long, so I hope you understood it. Replay the whole video if you need to pick up some things, but the whole point is understand the angle of inclination, and the angle of inclination is calculated by saying m is equal to tan theta. I hope you are going to understand this and you enjoyed this. Thank you very much.